Today's assignment is exactly like the assignment that you did on Alex last time. So let's look at number 1. M squared minus 7m minus 11, and that is divided by m minus 8. So what number do we put in the corner of synthetic division? You write equals 0, and then you solve, and you get m equal, not m to the 0, m minus 8 equals 0. Oh, that's a 2. Go ahead. Make fun of my handwriting. I can take it. So we put an 8 here, and then we write out the coefficients, but remember we have to check, did anything get skipped? So I have a 2, I have a 1, and then I have a constant that doesn't have an m. So I'm not missing anything. So we put 1, -7, and -11. Wow. I said -11, but that's not what came out. Okay. Drop the 1. 8 times 1 is 8. -7 plus 8 is 1. 8 times 1 is 8. And my remainder is -3. So everybody follow that so far. So my original was an m squared. So the result will be an m to the first. So it's going to be 1m to the first plus 1. And then we write plus the remainder, which is -3, over the original denominator, m minus 8. Uh-oh, she's not wearing a mask. Yes, this assignment, write it out this way. On Alex, sometimes it asked you for the remainder, sometimes it asked you for the equation. But in this, so this is the answer. We turn that into that portion. It's 1m plus 1. And then the remainder goes over the original divisor. Okay, let's do another one. Yeah, that's it. Look at number 6. A squared minus 28 over a minus 5. What do you notice here? We're missing an a to the first. So this is really a squared plus 0a minus 28. And I set the denominator equal to 0. And I put 5 in the corner. And then my coefficients are 1, 0, and -28. Do you guys get that? The 0 has to go in the right spot. Whichever one is missing gets the 0. Now we do the pattern. Drop the 1. 5 times 1 is 5. 0 plus 5 is 5. 5 times 5 is 25, which gives me a remainder of -3. Okay? So the original equation was an a squared. So the new equation will be an a. So 1a, or just a, plus 5, plus my remainder, -3 over a minus 5. Yep, and then if you need to, you can finish your Alex assignment. Okay. I don't care. All right, look at number 18. So 18 says -5 k squared plus k to the third, 18, plus 8k plus 4 divided by -1 plus k. Well, yes and no. Do you actually have to write it down? No, but we'll fix it. So we need to figure out the number that goes in the corner. So if I have negative 1 plus k equals 0, I add 1, and I get k equals 1. So we stick 1 in the corner. Now, are we missing anything in the numerator? No, but it is out of order. You have to write it, you have to have the coefficients in order. Do you need to rewrite the equation? No. But when we write down the coefficients, let's make sure that we put them in the correct order. So what goes first? This one, which would be 1, and then negative 5, and then 8, and then 4. So do you need to rewrite the equation? No. So to solve, drop the 1. 1 times 1 is 1. Negative 5 plus 1 is negative 4, which is negative 4. Yeah, you don't put the k's in the work. So it's always this times this equals that. And then whatever that says, just do it. So that one says negative 5 and positive 1. Negative 3. Yeah. Well, it will. It will. And then the next one, you do this times this equals that. Then whatever this says, you just do it. 8 minus 4 is 4. And then this times this is that. And then whatever this says, you just do it. A positive 4 and a positive 4 makes 8. Okay, now, my original equation was a k to the third. So these numbers will be k squared. So k squared minus 4k plus 4, and then we have plus 8 over the original, negative 1 plus k. You go down by 1. Exactly. Yep, that's a good way to say it. Now, what if this would have been a negative 4? Then the remainder would have been 0, and we wouldn't have this because it went in evenly. And that will kind of come up in our work a little bit later. What does it mean to go in evenly? Well, the numerator is a k to the third, and the denominator was negative 1 plus k. If your remainder is 0, that means one of these was also negative 1 plus k, and they would cancel, and the two remaining roots would be part of that function. Okay, one more. And this one's a little bit harder, so pay close attention. Go back to number 9. How is this one different? There's a 2 in front of the x in the denominator. So that causes two problems. First, when we set it equal to 0, we're going to get a fraction. So subtract 3, 2x equals negative 3, divide by 2, and x is negative 3 over 2. So that's going to make our lives a little bit more difficult. We have to multiply by negative 3 over 2. Okay. And at the end of the problem, it's going to do something else that we need to pay attention to. Divide it. Well, I'll show you in the end. So here's the problem. I drop the 2. How do I multiply 2 by a fraction? top times 2 and then divide it by the 2 on the denominator. So we will do negative 3 times 2 is negative 6, and then we divide that by 2, and I get negative 3. No. So negative 17 minus 3 is negative 20. What is negative 3 times negative 20? It's positive 60 divided by 2 is 30, which gives me a remainder of negative 8. Now, here's where people make the mistake. Because this is a 2, these two numbers are 2 times bigger than they're supposed to be. So I need to divide them both by 2. And notice I didn't touch the remainder. The 2 does not affect the remainder, which is weird, but it does affect the equation. So instead of 2x minus 20, I have to cut those in half, and I do x minus 10 plus negative 8 over 2x plus 3. So whenever there's a number in front of the x in the denominator, you're going to get a fraction, which makes the calculations a little bit harder, but you also have to divide the ending equation by that number. Exactly. Yeah, which would be a real pain, right? If this number was a 9, then those would be huge. But we'd have to pull that 9 out to write our answer. I'm just mean. So, here are the answers. You can find them on Canvas, but if you just want to come up and just use a single finger, if you use 2 fingers, then it kind of freaks itself out. Well, but if I make it too big, nobody will be able to see them. So anyway, feel free to write down all the answers and don't do the work because I love giving zeros. So, okay, get to work.